Alright, so if you got a new piece of paper like I did, you can title it Chemical Reaction Notes Continued. I like how mine got smaller. It looks funny. So on our first one, we did our first essential question: what determines a chemical reaction has occurred, and how can we tell a new substance has been formed? Alright, and we took notes. We know chemical reactions occur when a new substance was formed. Evidence that has happened: bubbles, production of gas, production of heat or loss of heat, production of light, or a precipitate, a solid coming from liquids. And we can look at chemical equations and look at the molecules of the chemical equations and compare them from the reactant side to the product side. And if they changed, then we created something new, right? So now our second essential question is how do chemical equations show the law? Actually, where's my green pen? Of conservation of mass. Okay, and this is a new concept that it's one of your vocabulary words. So you really need to understand the law of conservation of mass and what it is and how we can prove that it's a law that we follow. All right, and so the other part of this essential question is how can we determine that mass is conserved during a chemical reaction. Because we have to have a way to be able to prove that, right? All right, so before we can even think about comprehending this, we need to know what is the law of conservation of mass. What does it even state? All right, so how I did on the first one, I did 1A and then 1B. I'm going to do that on this one. Since this is question 2, that totally looks like a Z, but it's not. That's 2A. All right, so our first thing that we need to figure out is what is the law of conservation of mass? I wanted my thing to be purple. All right, So if we think about this, when we did our vocabulary, we talked about, well, what does conserve mean? All right, and then we have mass. So it states whatever mass that we start with, we're going to end up with, because we're conserving mass. We're pretty much like saving it, right? We can't lose any and we can't gain any. So the amount of mass at the start of the reaction which is the reaction side, or reactants side, sorry. I'm just going to write it on here again. That is our left side, right? So the amount of the mass at the start of the reaction will equal the amount of mass after the reaction, which is the product side, also the right side. All right. I'm underlined. I really wish I would have wrote mass in green, but I didn't. So masses are equal, pretty much. That's the sum of things. Law of conservation of mass. They're equal on both sides. So another way to kind of explain the law of conservation of mass, mass does not disappear. It simply just changes forms. During the reaction. Okay, and the mass of the reactant side, well, we'll just put reactants. Oh, I want purple. Is equal to the mass of the products, which are on the right side. All right, so we don't gain or lose any mass. It is it's just changed forms and it stays the same. All right, now to B. So now we know what the law of conservation of mass states. It's pretty much that mass stays the same. So now, how can we determine that mass is conserved during a chemical reaction? All right, and there's a couple ways we can do that. We can do that at a micro level and a macro level. So, the one that we already know how to do, you haven't really done it yet, but we know how to count atoms. All right, so we can count atoms. On the reactant side. And count the atoms on the product side. And if they are equal. No mass was lost or gained. Took notes before I did this, and I'm kind of changing them because I don't like the way I did it the first time. Okay, so what we can do is, so far, we have pretty much, you guys have just counted atoms of, say, this right here, just water, right? Just that element. We know that that subscript there, we have 2 hydrogens. There's no coefficient in front of the oxygen here and no subscript, so we know there's 1. And then you should be able to count these atoms, right? We have 1 carbon there and two oxygens. So if we can count the atoms of each formula, then we can figure out, are they all accounted for? All right. So you kind of already know a little bit about how to do that. Then what is going to be new, how we can determine this, is their masses. We can also measure masses on either side. Our reactants are on our left side, so we can measure the total mass of our reactants and measure total mass. And what's our other side of called? The products, right? The right side. And see if they are equal. So in all the ones that you do now, we don't have you balancing equations. We don't have you doing anything like that, but it's very important that you understand how to figure out if they are balanced and if their masses do add up, because whenever you get older and in chemistry, you're going to have to balance those equations, and reactions can't happen if you don't have enough of the right element. All right. So sometimes we need more molecules, and that's why we put those coefficients up there, because we don't have enough molecules, then that reaction's not going to happen. All right, so our essential question on this one was, how do chemical reactions show the law of conservation, and how can we determine the mass is conserved? Well, chemical equations, whenever we look at them, we know the law of conservation of mass states that mass is going to be equal. So whenever we look at our chemical equations all together, then we can look at their mass, and their mass is down here, and we can look at their atom amount, and if they equal, then we know that follows the law of conservation, right? So now we're going to do some practice problems on this, and we're going to do that together. Okay, so I'm going to title mine Practice Problems. All right, so number 1, I want everybody to write coefficient 2, and then H2 plus an O2 molecule yields, which is the arrow, coefficient of 2, H2O. All right, and we're going to label on here. These are the reactants on this side. This arrow means yields. And this on this side are the products. All right, now we're going to just count these atoms in this whole equation. All right, so first off, the assignment that you should have already done before that one, or before this one, I don't know where that paper is, but the first step we do, what do we need to do? We need to identify our elements, right? So on this side over here, I have or how do we identify our elements, I guess I should ask? We count capital letters, right? So over here, I have a capital H, and I have a capital O. All right, over here, on our product side, I also have a capital H, and I have a capital O. So that's promising. I have the same elements on either side, right? So now I need to count these atoms. So first off, I look, is there a coefficient? Well, yes, there is. What do I do with that coefficient? I multiply it by the subscript, right? So 2 times 2, I have 4 hydrogens. Then I'm going to go to oxygen. Is there a coefficient? No, so it's technically like an imaginary 1 right there. So 1 times 2 would be 2. Then I look over here on this side. I've already identified my elements. So the next thing I do, is there a coefficient? Why, yes, there is. It's that big number right there in the front, and it's a 2. So for H, what do I do with my coefficient? I multiply it to the subscript. So 2 times 2 is 4. And then oxygen, does it have a coefficient? Yes, it does. It's 2. It doesn't have a subscript, so that's the imaginary 1. 2 times 1 is 2. 4 hydrogens over here, 4 hydrogens over there. 2 oxygens over here, 2 oxygens over there. This is balanced. All the mass is counted for. I started with 6 atoms altogether over here. I ended with 6 atoms altogether over here. All right, so when you do these assignments and you draw them out like this, they're very simple, but you got to take the steps. All right, so here's another one. See, I don't want to run out of room. I won't skip too much. Okay, so this is an S, so sulfur plus Fe yields FeS. So we're not going to label them every time. Reactants, yields, products. So these things react, they yield this. They produce the products. All right. So on this one, we're not going to really count atoms. If we counted atoms, then there's 1, there's 2, there's 1, there's 2. But this time we're going to look at masses, because that was the second part of our thing. So if this was a problem you had on a test or an assignment or something, they would give you the masses of each one of these things. Sometimes they don't give you all of them, but this is 32. Sorry if that's hard to read. 56 G, and that G stands for grams, and then 88 grams. All right, so what you're going to do here is we need to add all the mass on the reactant side and figure out if that equals the mass on the product side, right? So we're going to do 32 grams plus 56 grams, and that's going to equal 88 grams. Then on my product side, I had 88 grams as well. So, do those equal? Yep. Do they have the same amount of atoms? Yep. So they're balanced. And their masses are equal. All right, we got 2 more. So this one is capital C, capital H, subscript of 4, so that's a molecule, plus coefficient of 2, capital O, and a subscript of 2, so that's 2 molecules of oxygen gas, yields CO2, so we know that's a gas, plus 2 molecules of water, H2O. All right, so in this one, CH4, we're going to say it's 16 grams. This 2 molecules of oxygen gas. We're going to say that's 64 grams. Over here, CO2 is 44 grams. And this water is 36 grams. Okay, so what do we have to do to figure out if the law of conservation is abided by? We have to add up the masses on each side, right? So down here, I would have 16 grams plus 64 grams, and that would equal 80 grams. Oops. And then on my product side, I have 44 grams plus 36 grams. And that would end up also equaling 80 grams. So I have 80 grams on this side, 80 grams on that side. Do those equal? Yes, so this is balanced. Masses are equal. All right. Now the last one. You're going to have some problems that are like this. Not that many, but you do need to know how to do it. So we're going to go ahead and cover it here, right here in the beginning. All right. So for this one, we have capital N and an A, and then capital L, capital C, lowercase l, NaCl, salt. All right, then we have plus H2SO4 yields NaHSO4 plus HCl. And on this one, they don't give us the grams of the salt, but they give us the grams of this one at 4.8 grams. They give us the grams of this one at 6.2 grams. And they give us, I guess I should say, the mass of this one at 1.825 grams. All right, so we have to solve for NaCl, which is salt. All right, so we're going to start by totaling. So start by totaling the side you can, because they didn't give us both the masses on both sides. So in this case, what side do we, is it the reactant side that we can add up the total, or is it the product side that we can add up total? In this case, it's our product side. Okay, so I'm gonna, since it's our product side, I'm just gonna drop down right here and go ahead and do it here, so I can write out my reactant side over here so I can remember what I'm solving for. I'm just bringing the whole thing down. All right, and then over here I had 6.2 plus 1.825 grams, and that's going to equal, I used a calculator, and I don't care if you guys do, ooh, yeah, that's right, 2.5. I don't care if you guys do, I just need to know that you know the steps. So that's my total over here on this side. Well, if the law of conservation of mass says that whatever I start with is what I'm going to end up with, then I know that if I have 8.025 grams over here, I should have started with that, right? So then your next step is going to be subtract the mass of the known, it was a reactant in this point because we know this reactant, so that's the known reactant I'm talking about, from the total product mass. Okay, and when we do that, we have 8.025 grams minus 4.8 G equals 3.225 grams. All right, so that was step 2. Then step 3, when you do this, you want to always check your answer. So you're going to plug the mass in. Okay, and when we do that, we have over here, we solved that NaCl was 3.225, so 3.225 grams plus 4.8 grams. When we add that together, it equals 8.025. And that's what we wanted, right? Because that's what we had as our total on that side from there, right? And that checks out, and our masses are equal. Hopefully I did not go too fast. I was trying to make this shorter than I knew that it was going to be because we did a lot of examples, but hopefully this helped you, okay, to revert back. What does the law of conservation of mass say? That it's going to be equal on both sides, the reactants, which is the left side, products, which is the right side, because we can't just lose things or gain things, all right? And so here are different ways and different examples that we do that. So I want you guys to keep all of these things with you. Please don't lose them. You can use them when you're doing other assignments, okay? Hopefully this helps. Let me know if you guys liked it, and if you think that we need to do this a little bit more often to help you more so, all right? Hope you enjoyed it.